In 1939, the Baltimore and Ohio Railroad unveiled a locomotive that changed everything. It was not the biggest, it was not the fastest. It did not set power records or win publicity stunts. But within 5 years of its appearance, every major railroad in America had placed orders for hundreds of units like it. Within 10 years, the manufacturing infrastructure that had sustained steam locomotive production for over a century began to collapse. Within 15 years, the last steam locomotive built for an American Class I railroad rolled out of a factory that would close its doors forever just months later. The machine that killed American steam was not a revolutionary prototype. It was a production diesel-electric locomotive, Unit number 103, built by the Electromotive Corporation for the Baltimore and Ohio Railroad. It was the first mass-produced, standardized road freight diesel locomotive in the United States, and it did what no steam locomotive, no matter how advanced, could ever do. It made itself ordinary, it made itself cheap, and it made itself impossible to compete against. The death of American steam was not a technical failure. It was an economic execution. And it began on a December morning in 1939, when a machine that looked nothing like a locomotive proved that the future belonged not to the biggest or the best, but to the one that could be built, sold, and serviced at scale. The American railroad industry of the 1930s was in crisis. The Great Depression had gutted passenger traffic. Freight revenues, already under pressure from trucking and barge competition, plummeted as industrial production collapsed. Railroads that had been profitable for generations found themselves unable to cover operating costs, let alone service the enormous debts accumulated during decades of expansion. Bankruptcy filings swept through the industry. Thousands of workers were laid off. Equipment rusted in storage yards, and the great locomotive builders, Baldwin, Alco, and Lima, saw their order books shrink to almost nothing. Steam locomotives, the technology that had defined American railroading for over a century, were part of the problem. They were magnificent machines, capable of extraordinary feats of power and endurance, but they were also labor-intensive, maintenance-heavy, and inefficient in ways that the industry could no longer afford to ignore. A steam locomotive required a fireman to shovel coal, a hostler to prepare it for service, a boiler washer to clean it between runs, and a small army of roundhouse workers to maintain the complex mechanical systems that kept it running. Every steam locomotive demanded coal, water, ash disposal, and a network of specialized facilities, coaling towers, water cranes, ash pits, turntables that had to be maintained at enormous expense. Diesel-electric power promised an alternative. Internal combustion engines driving electric generators, which in turn powered traction motors on the axles, offered a simpler, cleaner, and potentially more efficient system. Diesel engines required no firemen. They could be refueled in minutes instead of the hours needed to load coal and water. They produced no ash, required no boiler washing, and could run for days without the constant attention that steam demanded. The technology was not new. Small diesel switchers had been operating in American rail yards since the early 1920s, but no one had yet produced a diesel locomotive powerful enough and reliable enough to replace steam in mainline freight service. The Electromotive Corporation, a subsidiary of General Motors, was determined to change that. EMC, later reorganized as the Electromotive Division of General Motors, had spent the 1930s perfecting the diesel-electric passenger locomotive. Its sleek stainless steel E-units, the sleek stainless steel locomotives that powered trains like the Burlington Zephyr and the Santa Fe Superchief, had proven that diesel could match steam in speed and exceed it in reliability. But passenger locomotives were a niche market. The real prize was freight, the backbone of American railroading, where thousands of steam locomotives hauled millions of tons of coal, grain, steel, and finished goods across the continent every day. In 1939, EMC introduced the FT,
a freight diesel-electric locomotive designed to compete directly with steam on heavy mainline service. The first demonstrator units, numbered 103A and 103B, were delivered to the Baltimore and Ohio Railroad in December 1939 for extensive testing. They were unlike anything American railroads had seen before. 4 units coupled together, each powered by a 1,350 horsepower V16 diesel engine, delivered a combined 5,400 horsepower under the control of a single engineer. The units were semi-permanently coupled in AB-BBA configuration, with 2 cab-equipped A units on the ends and 2 cabless B units in the middle, creating a single locomotive consist that could be operated as one machine. The specifications told only part of the story. Each FT unit rode on a pair of 2-axle trucks, giving the 4-unit set a total of 16 powered axles. The diesel engines, EMC's Model 567, were 2-stroke V16 designs that had been refined through years of development and testing. They were reliable, fuel-efficient, and capable of sustained high output without the thermal cycling and mechanical stress that plagued steam locomotives at continuous high power. The electric transmission eliminated the need for reciprocating rods and complicated valve gear, replacing them with traction motors that delivered smooth, stepless power directly to the wheels. But the FT's real advantage was not in any single technical feature. It was in what the locomotive made possible at the system level. A 4-unit FT set could replace 2 or 3 steam locomotives on a typical freight run, and it could do so with a single engineer and no fireman. It could run hundreds of miles without stopping for fuel or water. It required no turntable, no roundhouse, and no specialized servicing infrastructure beyond a fueling station and a basic maintenance facility. It could be coupled to added FT units to match any power requirement, making it endlessly scalable in a way that steam, with its fixed configurations and incompatible designs, never was. The Baltimore and Ohio tested the FT demonstrator across its system throughout 1940 and 1941. The results, documented in internal B&O reports now preserved in railroad archives, were everything EMC had promised. The FT units handled heavy freight trains over mountain grades without the helper engines that steam required. They maintained schedules with a consistency that steam, vulnerable to coal quality, water conditions, and crew skill, could not match. They returned to service faster, ran farther between inspections, and delivered lower fuel costs per ton-mile than any steam locomotive on the B&O roster. But the B&O's test results were only the beginning. EMC, confident in the FT's performance, organized a nationwide demonstration tour that became one of the most important marketing campaigns in industrial history. The FT demonstrator, set number 103, still wearing B&O markings, was sent out on a 35-state, 83,764-mile promotional tour that visited 20 major railroads between 1940 and 1941. At every stop, the FT pulled freight trains under real operating conditions, hauling everything from coal drags to high-priority merchandise. Railroad executives, mechanical officers, and operating department managers climbed on board for cab rides, inspected the machinery, and studied the performance data that EMC's engineers presented in meticulous detail. The tour was a masterpiece of industrial salesmanship. EMC did not merely claim the FT was better, they demonstrated it on each railroad's own track with each railroad's own trains under conditions that could not be dismissed as laboratory optimism or promotional exaggeration. The tour proved that the FT could operate anywhere, in any climate, on any grade, with any kind of traffic. It proved that diesel-electric power was not a niche technology for streamlined passenger locomotives. It was a general-purpose replacement for every category of railroad service. The orders began arriving even before the tour was complete. The Santa Fe Railway, operating one of the longest and most demanding freight corridors in the country, placed the first production order for FT units in 1940. By 1941, the Southern Pacific, the Union Pacific, the Great Northern, and the Pennsylvania Railroad had all signed contracts for FT locomotives. By the time the United States entered World War II in December 1941, EMC had orders for hundreds of units, and the company's factory in LaGrange, Illinois was ramping up production to levels that no diesel builder had ever attempted. The war changed everything. The War Production Board, the federal agency that controlled industrial output during the conflict, designated the FT as essential war equipment and authorized its continued production even as it restricted the construction of new steam locomotives. The military's demand for reliable, fuel-efficient motive power to move troops and war material across the country accelerated the FT's adoption. Railroads that might have delayed dieselization in peacetime found themselves pushed into the transition by government policy and wartime necessity. By 1945, when the war ended, over 1,000 FT units had been built, and diesel-electric freight locomotives had proven themselves under the most demanding conditions American